Hey, everybody. My name is Patrick O'Halloran. I am with WhereScape. It's the top of the hour. Thank you all for joining. I'm going to give us about 2 minutes to let a few more people trickle in, and then we'll get started. I've been looking forward to this. Let me go ahead and share my screen. There we go. For those of you who just popped in, again, my name is Patrick O'Halloran. I'm going to give us about 60, 90 seconds to get started, just to allow a few more people to trickle in. This is being recorded, so if you have to leave during the middle, or if you're not here, and you obviously don't hear me if you're not here, but if you're not here, we'll send it a recording as well. There is a Q&A button at the bottom. I've got that window open. If you have any questions, feel free to type those in. We will either answer those if it fits in with our conversation, but at the end, there will also be a Q&A session as well. Got a little pop-up that said a participant has requested that captions be turned on. I'm still amazed by voice to text. That's still just magic to me. I used to. I was talking with David about this a while ago. I used to understand technology. I used to, had classes in microprocessor design and took assembly language classes and knew what was happening. And now it's just all magic.
Shh, don't say that.
So I'll give us about 30 more seconds. You know what? It's 2 minutes after the hour. If someone walks in a little late, they'll just have to catch up. All right. Hey, thank you for joining us. I'm here with Dave Langer, founder of the Data Science Guy, Dave on Data. He has taught hundreds in person, thousands remotely on all aspects of data and technology. We're going to talk today about dimensional modeling and machine learning. And if I can advance the slide without doing too many. There, we're done with the first bullet already. We're ahead of schedule. I'm going to spend a minute or two talking about WhereScape, who we are, what we do. Since we're sponsoring this, I get to be able to do that. Why dimensional modeling? Why is it? Why does it exist? I'm assuming a lot of you already know about it, but it never hurts to go back to the fundamentals and talk about the aspects of what dimensional modeling offers you. Talk about how it helps with machine learning. We'll have some real world examples. And then suppose you decide that, yeah, I do want to use dimensional modeling to help with my machine learning because I either have existing data or I can build something fairly easy on top of my existing data foundation. How do I do that? And then we will have Q&A at the end. I'm seeing Pennsylvania. I'm seeing Jamaica, Central Florida, Nebraska. Cool. People from all over the place. So WhereScape. WhereScape is a software company. We started 25 years ago in New Zealand as a consulting company, building data warehouses. Realized we were doing a lot of repetitive tasks, and those tasks facilitated that we built a tool to automate those tasks. Those tools we built became very productive and very powerful, and people started asking if they could buy those tools. So WhereScape stopped being a consulting company and began as a software company. We've got customers around the world. We've got about 1,200 customers or more in pretty much every industry you can think of, doing dimensional modeling, Inman, data vaults, data lakes, data lake houses, using pretty much every target you can imagine. And this pretty much describes what we do. We have a design tool that helps you profile source systems, build a conceptual logical model, tie your source system to that logical model, and then push it out to our builder tool where you can build a physical model, a lot of DDL, a lot of DML, a lot of Python or PowerShell scripts that generate and run your what I call data infrastructure. Just a real quick example of what it is we build. We've got data sources here. You've got ODBC connections, JSON files, Parquet files of some sort. You've got data analysts over here, which I now would include AI engines, machine learning. It used to be that the limiting factor in data warehousing was how much data you could consume. Then it seemed to be the number of data sources you could consume. Now it seems to be who's using the data. And the struggle with data warehousing now, building a data foundation, is getting data in the right format for your users, who now are not only dashboards and reports, but machines as well. Are what we call a NASCAR slide, lots of customers, lots of very happy customers, and then a slide for the very end with Q&A. with that, I will stop my screen sharing maybe. And Dave, I just did a very quick introduction for you. You're based in Boise,
Bozeman, Montana,
Bozeman.
another B town
Yeah,
in the
right.
Rocky Mountains.
Same general area.
Yeah.
We've talked before. You said you worked at Microsoft. You have Dave on Data now. How would you describe what it is you're currently doing, and what you're offering to people?
Yeah. So I've been in technology a long time. Uh, been a software engineer, been an enterprise architect, and I've spent about half my career working in hands-on analytics, starting with traditional BI and data warehousing, reporting, dashboards, that sort of thing. But these days, I'm mostly doing data science-y type work. I'm going to air quote that because it means different things to different people. We can certainly talk about what I think it means if you think folks would be interested in that. So I'm a data science consultant and educator these days. So I spend most of my time training people on how to use machine learning and other advanced analytics techniques, as well as also helping clients build and use machine learning and things like that more effectively.
Yeah, we talked a couple times remotely, and then we actually met in person in Las Vegas about 2 weeks ago at the TDWI, which used to stand for the Data Warehouse Institute, but now stands for Transforming
Transforming
Data
data
with
with
Intelligence.
intelligence. Yeah.
Yeah, you were teaching several classes there.
Mhm.
Um, so we're talking about machine learning. We're talking about the way this whole topic came up is I've been told that dimensional modeling is passe and that there are much better ways of doing things. So in your experience, how did again we've got a lot of data modelers and analysts on already, but at a very basic level, why dimensional modeling? What was Kimball trying to do 25 years ago?
Yeah.
That what was the problem he was trying to solve?
Yeah. So from my perspective, because I've been a Kimball guy from way back, I will admit, like most technologists who've been around a long time, I have certain biases and opinions about things, strongly held beliefs and convictions. So I'm a Kimball guy. Proud to say it from way back. And in the early days, Kimball was trying to achieve arguably two main goals. And you mentioned these. One was handling the physical limitations of the technology back in the day, right? So way back in the day, some folks might not know about technologies like this, but like OLAP cubes, right? OLAP cubes were big back then, and OLAP cubes were essentially a way to cache data in an aggregated form to increase performance. Now, the only downside was you're using aggregated data. You're not getting at the lowest grain of the business process. You're not getting at the transactional stuff. So Kimball was really trying to say, look, is there a way, given the limitations of technology back then, could we get away from caching data in an aggregated form as the default way we served up data? And can we actually capture it in such a way that we can access the transactional data and then surface it in such a way, and that's the second aspect, and you mentioned this as well, that's easy for folks to understand and consume. And that's where dimensional modeling really came into play. Now, as time has moved on, as you correctly indicated, the technology aspect has become less and less important. Databases are far more powerful. We got more powerful hardware, blah, 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 all that, cloud, all the things. So it's more shifted to this idea of like ready to use data. And dimensional modeling is a great way to structure your data in such a way that the maximum number of users in your organization could potentially use it. Because it'll tend to be more, when done right, the Kimball model tends to be more accessible to a lot more folks, not necessarily technologists, not IT people, but also quote unquote business folks as well.
Yeah, one of the phrases I hear a lot is data mesh, where individual departments, individual domains are creating their own data products. And I think Kimball lends itself to that well because now you have a standard way of accessing the data and approaching the data. So if I'm in HR and I need to go look at purchasing data, I don't have to reteach myself a whole new architecture and a whole way of approaching the data.
Yeah, in theory, assuming that you've built all the DIMs and facts that the HR people need, right? That's
Yeah.
always the sometimes that's true, sometimes that's not. But in general, yeah, assuming that you've got your bus matrix filled out using, the Kimball methodology and you've filled in all the conformed DIMs that you need and then the facts that you need, yeah, that's pretty true.
You said in theory they're the same. There's a quote I heard a long time ago, which is the difference between theory and reality is that in theory they're the same.
For me, it's always been time and budget,
Yeah.
theory and reality. That's actually usually the gap.
So you mentioned grain, and how because of limitations of processing, because of limitations in throughput and data transfers and all that, OLAP cubes and things tend to deal with aggregates and averages and large sums of data, as opposed to dimensional modeling, where you can get down to the finest grain you can, individual transactions, individual actions. I'm assuming that really helps with machine learning.
It absolutely does. It absolutely does. So the story I like to tell is that I first learned about machine learning while I was getting my master's degree. And at the time, I was going to school at night and I was working at Microsoft during the day. And I worked in the Xbox division, supporting manufacturing and supply chain for Xbox. And we had a Kimball style data warehouse. And when I was taking this machine learning course, it just clicked. I was like, wait a second, we can use our data warehouses far more than just as for reporting and dashboards. We can actually use it like a crystal ball. It'll allow us to actually take that historical data, feed it into a machine learning model, and if we do it right, we should be able to accurately predict future events, right? That's the whole promise of machine learning predictive models. And what struck me was that all of that clean and tasty enterprise data was in that raw format that you need for machine learning. You can't really work with aggregates. You have to work with the low level data, at least at the start. You might aggregate it as part of building your machine learning model, but typically you don't. It's usually closer to the transactional grain than it is to the aggregated grain. So for example, um, using Cognos or SSAS, which are OLAP cube technologies, right? Usually wouldn't give you the data that you actually need to build a good machine learning model, but a Kimball style data warehouse with all the low grain data could be used for that quite well.
Yeah, you mentioned using, excuse me, um, using your Kimball architecture for training for machine learning and doing predictive analysis on. I don't know if you mentioned today or yesterday. Yep, supply chain,
Hmm.
um, things like that. Um, I have been to a lot of AI events, and a lot of the attendees I'm going to at these events are still trying to figure out what exactly what AI, what exactly what machine learning are. And I've learned to describe it on a spectrum. It's not like it's a switch, you have it or you don't have it. Can you give some examples of someone who's just getting into it, looking at capabilities, what kinds of things they might be using for machine learning? You
Right.
mentioned predictive analytics, stock
Right.
keeping.
Yeah. So let me just opine for just a quick second, just
Sure.
so that we can level set everybody. So I have an educational background as well as professional background in computer science. AI is an umbrella term from the computer scientist perspective, artificial intelligence. And there's many aspects, areas of study, technologies that have been developed that all fall under that umbrella of AI, one of which is machine learning. Now, technically speaking, what people think of as AI, ChatGPT, LLMs, large language models, that sort of thing, is just a specialized form of machine learning called supervised learning, which is a predictive model. So AI is in the current nomenclature is a predictive model. Now, granted, it's a very large, very sophisticated predictive model, right? We all know about how much processing power, OpenAI needs to build ChatGPT, right? It's insane. But in the end, it's still a predictive model. It's predicting the words that it sends back in response to your prompts. So from that perspective, what we really need to do is start thinking about not necessarily AI anymore. We just need to think about machine learning along the spectrum, like you're talking about, which is the biggest, most powerful predictive models that we know of right now are what we call AI, LLMs, ChatGPT, Claude, that sort of thing. Okay. That being said, it's a predictive model, like I said. So if you think about machine learning along that spectrum, you can create all kinds of predictive models, ranging from ChatGPT to something like, is this claim fraudulent? Should we approve this insurance application? Can we predict whether or not a student is going to drop out of our university? All of those sorts of things are possible, as well as forecasting. You can also use machine learning predictive models for forecasting. And in fact, some of the state of the art techniques for actually forecasting sales and demand and things like that actually use machine learning techniques, the kind of stuff that is typically taught in a computer science curriculum, which is a bit of a shift from statistical type techniques to more machine learning based techniques. So predictive modeling obvious is the obvious one. That's the one that gets all the play. But that's not all. In a lot of places, you have lots of data. but your data doesn't have what's known in machine learning as a label, which is an outcome of interest. And the easiest way to think about that is like some sort of yes no indicator. Is this claim fraudulent? Yes or no? Is this student likely to drop out of university? Yes or no? A column in your data set that has like yes no indicators, that's what's known as a label. It's an outcome of interest. Most of the world's data is not labeled. So another form of machine learning that's actually really, really super useful in practice is what's known as unsupervised learning. And that's where your data doesn't have these labels, right? Cluster analysis is the quintessential example. So that's another form of machine learning. And by extension, cluster analysis is AI. So somebody just getting into it really needs to say, look, along this spectrum of AI-ness, if you will, where where should we actually start working first? Where are we actually going to get the potential biggest bang, the potential ROI for the least amount of effort? And typically, it's not trying to work with LLMs because those are the largest and most complicated types of machine learning. So it's usually a good idea in the early days to scale it back and try something a little bit easier, a little bit more understandable to your business, something with more of a direct line of sight to business ROI, and start there. And if you're under pressure from your executives, you can say with a straight face, boss, this is AI.
I like that. Yeah, it's one of those things that everybody wants, but nobody quite knows exactly what it is.
Mm-hmm.
You mentioned at Microsoft you had been in charge of Xbox supply chain, and you had analytics in a Kimball style that you'd been gathering for that. How were you using that pre-machine learning? What was that data being used for?
Yeah, and just so we're clear, I was not in charge of the supply chain.
Okay.
Okay, I just want to make sure that was clear. I was at the time I was the architect for the BI and analytics platforms for um, Microsoft's Xbox supply chain. I eventually became the senior director of BI and analytics and actually ran the team. Yes, but I don't want anyone to be like, Dave, you were not in charge the whole thing because I wasn't. Okay, so before my epiphany in my machine learning course that I took as part of my master's degree, we used our data warehouse for exactly what you would expect for reporting and dashboards. So I worked at Microsoft, so not surprisingly, we were on the SQL Server stack. So we had all the things. We had SSAS, SQL Server Analysis Services, OLAP Cubes. We had SSRS, SQL Server Reporting Services. Uh, I was at Microsoft when Power BI first rolled out in the early days. So of course we had Power BI dashboards all over the place, not surprisingly. So all the traditional stuff that under the Gartner maturity model would be classified as descriptive analytics, reporting on what happened last week, last month, last quarter, that sort of thing. And that was predominantly what we did. The analyses that we did, generally speaking, were quite light, as most companies do. And what typically ended up happening was if any of our quote unquote business partners were interested in doing analyses, more often than not, they exported the data out and analyzed it in Excel, or they asked for a data dump or a data pull, and then they analyzed it in Excel. So
And go ahead, go
right
ahead.
in the whole descriptive analytics, very low level of maturity kind of spectrum.
And I assume that was all backward looking. All the reports and dashboards were here's what had happened.
Right. Right. And of course, there was a certain amount of diagnostic analytics that people tried to do as well, right? For example, if we had a bad batch of components or consoles or something like that, trying to root cause analysis, that sort of thing, right? Classic manufacturing supply chain kind of thing. But typically that was all done using, either Excel or tools outside of the official ITBI stack. So,
I do have to say I was very disappointed when the Connect broke on my Xbox. So I should probably have talked to you about that because it was actually really, really handy.
oh yeah,
I'm,
the Connect loved it. Yeah, it was great.
yeah.
I use that as an example in some of my machine learning courses because there was a machine learning model that made the Connect actually work, recognized your body movements and stuff inside the device.
So you already had a Kimball style architecture for doing this look back and diagnostic and other kinds of business analytics that you were using. But suppose I don't have that. Suppose I've got a data lake, I've got a data vault, I've got some unstructured, semi-structured data. How do I go about what should I look for first? What are some easy wins that I can say, well, if I can model certain areas, certain types of data, that would give me, as you said before, the most bang for the buck.
Right. So it's a great question. And the advice that I give is the same advice that I've followed myself. So I'm preaching what I do, if you will, and that is look at the KPIs. Look at the KPIs that your managers are being held accountable to, or your manager's managers being held accountable to, or even farther up the chain. And in general, that's a great place to start. And then once you look at the KPIs, then look at the stuff that got them worried. I mean, I'm going to be completely frank. Look at the stuff that actually determines whether or not they get a bonus. And if you can find that, right, this is where they get a bonus and things aren't going well, that's a great place to say, is there a way that I could apply advanced analytics in this space somehow to positively drive that KPI? For example, you might be able to perform a cluster analysis around things related to that KPI of interest. Let's say, for example, let's say you're a university and you're worried about students dropping out for whatever reason. So you might do a cluster analysis, for example, along those lines of the students, right? Where your rows of data in your data set are the entities of interest, which are students, and then the columns are their behaviors and attributes and characteristics, and you cluster them. And then what you can do is take a look at those clusters and then start applying, this idea of like, well, is this cluster likely to, for some reason, drop out of a university? Are these people not? So on and so forth. And that becomes insights that you can then use and present as part of some sort of data story or presentation or something like that to the executive. And because you're addressing something that the leadership cares about, they are far more interested usually in the output of what you have to produce than, for example, creating yet another dashboard. Been there, done that, by the way. Built many dashboards myself, a lot of which never got used very much.
Or got yeah. Um, I'm used to seeing so many monitors up on the wall with KPIs and dashboards and things and going green, yellow, red. That the idea of being predictive about it is enticing. Um, I'm primarily a technical creature. You're primarily a technical creature. But in talking with you, you've definitely got a business sense. I think one of the things we talk about when we talk about building data warehouses is it's typically a technical task that involves a lot of technical tools, including WhereScape. I can talk about that in a little bit. But it should primarily be a business function that we need to get the idea of building a data warehouse, an analytic system, AI and stuff to answer business questions, not answer technical questions.
Mhm.
So we kind of make a push to encourage people to, if they're in a data engineer, if they're a data architect or things like that, expand their views. I think a lot of the audience today is going to be data analysts who are already closer to the business. Um, but you mentioned, finding the key KPIs, the things that are near and dear, being bonuses to executives' hearts. Um, do you see a problem with AI being treated specifically as an IT function or as a technical tool rather than as a business tool?
Yes, and I'm going to make an assumption, Patrick, that you're using AI as the umbrella term as I described earlier, that
Yes, machine learning.
I opined
Yes, yes,
about
yes. I
earlier.
have to retrain myself.
Because
Patrick
then,
learning.
yeah, because if we don't, then we have to start talking about data science, right? And then that's another can of worms we have to open
Okay.
up. Okay. And generally speaking, the answer is that I come from an IT background and I had to learn the hard way, especially when I moved into data, that technology is great insofar as sometimes executives and business leaders are looking for certain check boxes that they can check off. Yes, we're doing this and yes, we're doing that, which is totally fine. And, just the reality of the situation. But that in general, they also don't care about too much about the how. So one of the earliest mistakes that I made, it was telling people about the algorithm, the machine learning model that I used, and to as a presentation for the insights that I found, and nobody cares. Nobody in that room cares about the how. All they care about is the what. Why am I here, Dave? Well, what's the insight? What's the so what factor? So moving this idea that yes, these are technical skills for sure, but they actually serve, these are technical skills that serve quite readily business concerns is super important, right? Which is different than hardcore software engineering, right? Which there isn't necessarily a direct correlation. And when I was a software engineer, that used to bum me out big time, right? That nobody cared about my beautiful object-oriented design, about
Yeah.
my design patterns. Nobody cared in the business. So that was a big shift for me, was to be like, okay, you know what? All of my technical skills are just an enabler for me to get to the so what. And that allowed me to get into the room and have conversations. So that's what folks really need to think about, especially if they come from more of a traditional technical background, especially if they're on a traditional BIDW team, where there's this kind of culture or operating model where oftentimes people are just taking in requests. I need a new dashboard. I need you to change this. I need you to change that, which is all well and good. You have to have descriptive analytics. You have to. But a lot of these folks want to move beyond it. And the way they move beyond it is by saying, look, how do we actually get these technical skills and then actually evangelize them as addressing business concerns? How do we evangelize these as potential business skills, not just technical skills, but also business skills as well? Along the same vein as pivot tables. I mean, pivot tables is arguably in Excel is arguably a technical skill. However, the perception from business people is like pivot tables are the best thing ever. So we need to get like machine learning and data science and analytical kind of technical skills into that same realm as pivot tables in Excel.
Yeah, I come from a very academic, very technical background. I did before my dad taught physics, and I was raised up in a university environment. That's where I grew up in a college town. And probably one of the best skills I developed was being able to not over-explain things. I always thought that, if someone asked me a question, I need to go into all the minutia, and you talked about that. As soon as you start introducing Greek letters, you've probably gone too far.
Yeah.
If
Yeah.
you have to use Greek letters in your explanation, for most people, that's way too far. We've got a couple questions here. I'm going to go ahead and submit them. How familiar are you with machine learning? I'll go ahead and submit that one, and I will submit. How interested are you? Are you using machine learning now? I'll go ahead and submit that one. Oh, it looks like I can only launch one at a time. And I see that someone has their hand raised in the attendees. I don't know if that's an accident or on purpose, but if you have questions, there is a Q&A button. So if you do have a question, feel free to type anything you need in there. Excuse me. You mentioned Microsoft supply chain. You've worked with a lot of people in a lot of situations. Can you describe some other examples of real world examples of where you've helped move someone from doing this after the fact analysis to being more predictive in what they're doing?
Yeah, there's quite a few examples. For example, one project that I worked on was for one of the state governments here in the US, which will remain nameless. And they were interested in trying to create a machine learning model that could accurately predict whether or not a unemployment insurance claim was potentially fraudulent, because they had been doing that specifically by hand. For example, they had a fraud team and they would comb through the historical data and they would try and look for patterns by hand, and they would try and hard code these kinds of rules. Like if, and this is no joke, by the way, if somebody used this particular middle name in their claim application, they had noticed that that was disproportionately associated with fraud, this one particular middle name, which, is well and good. In theory, a machine learning model will do exactly the same thing. Excuse me. But what a machine learning model will do is do it at scale, far, far, far more encompassing than what a human could do. This team, what the machine learning model learned from the data, it would take this team many, many years to figure out, if at all. So machine learning was great for that. So that was a great example of them moving away from hand comb through the historical data, looking for things, to actually moving to more of a predictive model. And one of the things they found most interesting, by the way, was not just the fact that the model accurately predicted fraud based on the historical data, but also they were super interested in what the model found to be important for predicting that fraud, which was stuff that they had never thought of before.
Yep.
So that's one example. And I got more. If you want more, I
Okay.
got more.
I imagine things with that middle name is, as a human being looking at that, I'm sure there's confirmation bias where if I see that middle name again, I go, oh, that's another one. That's another one. And I'll,
Possibly, right? Yeah,
conveniently
because
ignore the 99 that didn't have that middle name.
you see, that's my rule. That's the rule I figured out. See, look at that. That's my rule. That's my rule. That's my rule. I'm good. Look at me. Look at me. Look at me. Which
Well,
is
people,
human nature. Which is human nature, right? I mean, just the way it is.
yeah, sometime in my 20s, I decided I would adopt the attitude of egoless programming. And it's like Zen. I never quite got there. There was always some ego there in what I was doing about that's mine. I came up with that solution. I'm a
Okay,
smart
there's
guy.
there's some sort of meme potential for the egoless software engineer. I'm just seeing it, right? I gotta think about it more, but because I used to be a software engineer and I certainly was not ego less, that's for sure.
Okay, so I do have a question that fits in well right now by anonymous attendee. Um, I'm still struggling to understand the value of why a Kimball architecture would help with machine learning. My experience with machine learning is very basic. I've always thought people use data for machine learning that exists in data lakes or the likes. So, what advantage does Kimball architecture have for machine learning over a data lake?
It's a great question. And the answer is convenience, quite frankly. So as a consulting machine learning person, data scientist, whatever you want to call it, when I find out that my client has a Kimball data warehouse, that makes me happy because it means that I can get more done with less effort. And let me give you a specific example. Dim date. So a date dimension in the Kimball style, typically if it's done well, has many, 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 many columns for various aspects of a date. Is it a weekday? What day of the week is it? Is it a holiday? Da da da, right? All of these kinds of features. Those features end up being quite useful in many, many real world machine learning scenarios. If they're already built into dim date, I don't have to build them myself in my Python code, for example. So that's one example of the convenience factor. Here's another convenience factor. A accumulating snapshot fact table. Yeah, this is one of the more relatively advanced design patterns from the Kimball style. And basically think of it as a table where there's a column, and each column represents essentially a step in the business process. And usually what gets inserted in there is some sort of key reference to dim date, right? This step happened on this date, that sort of thing. Accumulating snapshot fact tables are awesome once again because typically if they're modeled well, you've already gone through the rigmarole of trying to understand the business process step by step, and you've already figured out which steps are the most important, and they're embodied in the table. So as a data scientist, I can just pull that data directly and start using it in my machine learning models to explore if any of those things are important. Now, all that aside, there's also one underlying foundation element. Generally speaking, the data quality that you're going to pull out of a Kimball style enterprise data warehouse is going to be very, very high because all of the data checks have put in place many years ago, oftentimes, that sort of thing as well. And that's also very nice because I'm spending less time cleaning the data because it's already been cleaned and normalized at the enterprise level. So it's mostly about convenience. And it's also about also tripping in your brain as well as the machine learning practitioner, what sorts of things are potentially important to the business process because they're typically embodied somewhere in the collection of DIMs and facts in the data warehouse.
Yeah, one of the things in WhereScape is we auto generate dim dates, and there's 90, 100, 110 columns, attributes on that. Um, things like, is it a holiday? Is it a weekend? What fiscal week is it? What fiscal
Mhm.
year is it? What day? What's the Julian date? And the nice thing about that is I can create different dim dates for different locations. Maybe I've got
Mhm.
holidays in one country that I don't have in another. Um, and that stuff is gets it out of my head and makes it reproducible and consistent so that everyone in the UK knows that December 26th is Boxing Day and it's a holiday, or every other Friday is a bank holiday, whatever they do in the UK. That's the way it seems to me. Is every other Friday seems to be a national holiday.
Yeah, and that's a great example as well, right? Because if you're new to machine learning, and let's say that you haven't been on the data warehousing team for the past 2 decades, right? You can start going in and looking at these schemas, start looking at the tables themselves, and it helps you understand if this was in the data warehouse in the first place, it must be important for some reason. Why would they go through the trouble of modeling it and populating it and keeping the data clean if it didn't have some sort of value? So it also helps you in the process of brainstorming your features, the columns that you would feed into your machine learning model. Now, that being said, doesn't necessarily mean that your data warehouse is the be all end all of where you pull your data for a machine learning model. You might certainly pull data from additional sources as well. However, typically in my experience, what I start with is I start with the data in the data warehouse, assuming that it exists. And then I reach out to other types of data if needed. For example, from the US federal government or from maybe a data lake where maybe they're storing log records, right, in a semi-structured format in the lake or whatever it might be as well. But typically what ends up happening is when I have access to a good Kimball style data warehouse, that becomes essentially my center of gravity. It's usually the center of where I pull most of the features that I use, and then I reach out from there to other data sources.
Yeah, one of the questions came in: is Kimball a bit too rigid comparing to Data Vault? And I can take that one on. I've got a little bit of experience with Data Vault. Data Vault's a specific methodology that composes several pieces. They'll describe it not as an architecture, but as a methodology that involves peoples and processes and things like that. I have to say that part. But when people think Data Vault, they think hub satellites and links and specific architecture. What Dan Linsing will tell you is that you've got the raw vault, which is essentially a one-to-one copy of what you're importing from the source systems, and you almost never, ever, ever use that data directly. You're going to create what he calls a business vault on top of that, or even he advocates this, just creating facts and dimensions on top of that as views. So you've got your raw vault that has the semi-curated data. You've got your business vault that has views on, that has access to that data. And I forget exactly what he calls it, but all the business rules and things are taking data from the raw vault and implementing that as star schemas. So actually, he recommends that you put views, if it's appropriate, facts and dimensions on top of your data vault. Excuse me. I said to you earlier, I've got this little bit of a cough that never seems to quite go away. Um, Data quality. It's become so ubiquitous in talking about machine learning and other things that I have been forbidden at certain conferences from saying garbage in, garbage out. I'm not allowed to say that anymore.
Why not? It's just as true now as it was when it was first coined.
Yeah. But it's so overused that I'm working on another phrase. I haven't quite figured one out yet. But
Fair
um,
enough.
does Kimball style methodology with its breaking things into facts and dimensions, does that, I'm assuming that lends itself better to data quality checks and data governance than just a data lake where you're just pumping in data.
In general, yeah. So in to be fair, I mean, that idea is more of an enterprise data warehousing methodology truism than Kimball specific, right? If you've got like an old school Inman style Snowflake data warehouse, ideally you've still got all the same kinds of data quality checks as you would have in a Kimball data warehouse. So tomato, tomato to a certain extent, as far as that goes. Um, but once again, people might be asking, well, Dave, don't data scientists, machine learning people, don't they just want to go access the raw data? And typically the answer is yes, mainly because what they're looking for is maximum flexibility. Once again, what they want to do is they want to avoid any sort of aggregation or any sort of pre-processing of the data that doesn't give them the flexibility that they need to engineer the best features, the best columns to feed into their machine learning models. Now, that being said, once again, a well-designed Kimball data warehouse from the get-go is looking at trying to store high-quality enterprise-grade transactional data. So oftentimes, that's basically all you need. And so you've got sufficient data quality. Now, here's the thing. If you're a quote unquote data scientist type person, you know how to write code. You know how to write SQL, you know how to write Python or R or whatever it might be. So you're probably okay going to basically any kind of data format that you want, right? Whether that's, DIMS and facts in your enterprise data warehouse or a CSV stored in some sort of blob storage in the cloud or whatever, data lake, whatever it might be. Because you're like, look, I can just write the code and work with it. The question isn't so much necessarily can you work with the data? The question really boils down to how easy is it to actually, how quick can you get to a good result that the business needs? That's what you're really worried about, not so much the technical aspects. And yes, even though I can access any kind of data in any kind of format and any kind of technology because I have the coding skills, it still benefits me to actually get things done faster. And that's where data warehousing and more formal data structures are really, really super useful. And again, as I mentioned earlier, and it bears repeating, sometimes I have to go beyond the DW, no matter what its form. Sometimes I have to go past the enterprise blessed, data governed data sources because I need more and different types of data. But usually, once again, if I have access to a good data warehouse, that usually forms the core of the data, and then I go outside for other types of data.
Yeah, and again, representing WhereScape, what I have to say is that one of the things I talk about with machine learning and AI and data quality is having a consistently generated way of enforcing governance standards and quality standards lends itself very, very well to having good, clean data at the end. I think we all know the potential problems of longer training times and bad results and hallucinations if you start feeding poor data into an AI machine learning engine.
Yeah,
But
we don't call those hallucinations. That's more of an LLM kind of thing.
okay, okay.
Those are just errors. It's just old-fashioned errors.
Uh, but I'll throw in one more plug for WhereScape and just say, like I said, the idea of being able to generate large models very quickly, prototypes, being able to change the format of data, being able to change, maybe I create a dimension and then realize I need to add something to it or take it or break it into two dimensions. The idea of automation allows you to do that very, very quickly. Machine learning and how to get data formatted and what to put it in. There's no single right answer. A lot of it's going to be a lot of self-training and learning on how to do that. Automation and WhereScape will definitely help with that. I've got a couple other questions about maybe I mentioned this before. How do I adapt my existing data? We talked a little bit about that. You talked about find the KPIs, find the important things, get those in front of. From my own ignorance, I've got a dimensional model. I've got facts. I've got dimensions sitting somewhere off the cloud somewhere or on-prem somewhere. How? I'm just curious. How do I get that data into a machine learning engine?
Yeah, I mean, there's many ways to do this, right? If you're on a particular cloud provider, let's say you're on Google Cloud. I'm not, by the way, I'm not endorsing any particular cloud provider. I'm just using them as an example. So GCP, Google Cloud Platform, it's going to vary based on what cloud platform you're on and what technologies you have access to. But the classic strategy at a super high level, irrespective of these individual architectural decisions in terms of your technology stack, is more often than not, you're pulling data from some sort of data storage that supports SQL. It speaks, if you will, SQL, right? That could be a formal RDBMS. It could be some sort of big data solution that has a SQL interface on top of it, like Spark, for example, or Databricks. And what you're doing is you're often pulling data, and usually more often than not, you're usually pulling a lot of cleaning and transformation logic for engineering your features and all that kind of stuff in SQL, pulling that from the storage engine, ideally joining them all up in some sort of storage engine, which is usually more powerful than your laptop, and then pulling that into something like Python or R or something like that. And then what you get back essentially is what's known as a data frame, essentially a table of data, and you feed that table of data into your machine learning algorithm. So one of the things that always cracks me up is I teach a course on how to do data wrangling for machine learning using Python. And people show up and I'm teaching them how to use Python to like wrangle the data and work with entire tables and join them up and all these kinds of things. And inevitably somebody raises their hand and says, "Can I do this in SQL?" The answer is yes, of course you can. So um, that's typically what ends up happening is in most of the client situations I'm in, most of the data is in some sort of data storage technology that speaks SQL. So you fire off your SQL, do a bunch of stuff, pull the data back, and then that net result, that data frame, that table is then what gets fed to the machine learning algorithm.
What is considered a large table? How much data are we talking about that you're feeding into? You being a consultant, the answer is going to be it depends.
I
Um,
used to be an enterprise architect. The answer is it depends.
yeah. Once,
Most people would be surprised, right? We have a tendency to be overly fascinated with quote unquote big data sets, especially in the technical community, because they represent an interesting engineering problem and it's legit, right? However, I will tell you, I've been doing machine learning now for 13 years, something like that, 12, 13 years. And most data sets in the real world that I've worked on or worked on with my clients are a lot smaller than you'd think. So, oftentimes less than a million rows of data.
okay.
A lot of times, quite frankly, a lot of the times, this is the term that I tend to use more than like big data and small data. Most of them are Excel sized.
I was going to say, isn't a million rows the limit on Excel now? Something.
I mean, that's the technical limit. In practical terms,
Yeah.
Excel will choke most of the time. But yeah.
Excuse me. Um, so I've gone through my list of questions. We've got a question that's sort of peripherally associated with this. We develop features from our data warehouse to train an ML model. Once the model is trained, we pointed at our real-time transactional source where the data is formatted in JSON. The challenge we have is recreating the features in real time against the JSON. So if I'm using Kimball style or something to train a machine model, um, how do I handle data that's maybe JSON data or CSVs
Mhm.
or?
Yeah, so in a production scenario, right? So ML ops, machine learning operations talks a lot about these various characteristics. You have a couple of different pipelines of data, right? So for example, you have your training pipeline, which is what the person was referring to. We built that from our Kimball style data warehouse. Now, if I understand the situation correctly, the data that's in said Kimball data warehouse came from JSON. So there was some processing pipeline upstream in the data engineering, or what we used to call ETL in the old days, right? ETL processing pipeline that takes the JSON, cracks it open, applies some rules and transformations, and then feeds it into a relational model, right? Tabular model. You essentially need to duplicate that in the JSON if you're running, right? Because that becomes your what's known as your inference pipeline, where I'm actually taking the raw data in and I got to transform it into a format that the machine learning model understands before it can make a prediction. So essentially, what you need to do, ideally, is you would look at that, and hopefully there's some code reuse between your upstream data engineering ETL pipeline used to feed your data warehouse, and you could also use that potentially in your inference pipeline as well.
Okay, so if you can't get to the source system directly, you're only getting things through an API or some other way of JSON files. We're essentially going to load it into our
Right. So
data
machine learning model,
foundation as broken apart into the individual attributes and then use that.
yeah, the most commonly used machine learning algorithms in practice require tabular data, not hierarchical document style like JSON or,
Mm-hmm.
the stuff that NoSQL databases are pretty good at, like MongoDB, things like document databases. It only understands tabular. So if you build a model using tabular data, what you're saying is I'm going to put it in production, my inference pipeline has to transform any of the data sources into that tabular representation before it can be used. And that's just part of the reality of the situation. So it needs to be, as part of your project planning effort and as well as maybe your early POC or MVP efforts, you need to verify, okay, like, look, wow, if we're actually really dependent on JSON, what's the actual data quality of the JSON coming in? And I will speak purely from my own experience. So if folks take that as a single data point, typically what I've seen most of the time when folks rely a lot on JSON is that the data quality can be potentially potentially spotty. Not always, but generally speaking, right? Especially if it's in a hierarchical document, kind of loosey-goosey kind of JSON format, you can run into all kinds of problems. And that's just something you're gonna have to take on as part of your inference pipeline work, if that's the case.
Yeah, one of the things I do in addition to hosting a lot of webinars and going to shows is I do record videos for our marketing team. And last week they asked me to do a 5-minute video. They gave me three choices. One of which is how do I break apart a JSON file and get it into a database very, very quickly. So I will work on that and hopefully have that done in a week or so.
Yeah, I mean, if you're working with like an API endpoint, typically the JSON is relatively structured, so that's
Mhm.
usually not a problem. But if it's truly JSON representing arbitrary document structures, then it can be quite difficult.
Yeah, what I thought was interesting was so we've got a file parser in WhereScape that automatically splits apart JSON files, XML files, Avro, Parquet, all these different file types, and whether they're coming from a file or coming from an API. I ran into an interesting use case where someone was getting JSON through a table. They were getting a table with a big long text field, and inside the big long text field was the JSON file.
Mhm.
So we had to manipulate our application to, instead of reading from a file or reading from an API, to read from a select statement, which was kind of a nice way to do it. Plus, it was encoded. It was encrypted. So this is on Google BigQuery, so they had some way of decrypting it as they were pulling data out, which is, I thought, a pretty cool way of doing that.
One thing I will say, and I've seen this as an anti-pattern before, because I love this question, by the way, if you can't tell, is that often will end up happening in practice, especially in larger organizations, is the data warehousing team, the data warehousing organization has quote unquote figured out the logic for breaking apart, for example, these JSON documents and then populating the warehouse. And then what ends up happening is oftentimes is a different team ends up building the production machine learning environment and maintaining it. And oftentimes they don't reuse all of the work that the data warehousing team already went through. They reinvent the wheel, right?
Mhm.
I used to be a software engineer and I loved to cut code from scratch. As an enterprise architect, I hated that, but so there's a constant balance. So that's one thing I will mention is if you've already figured this stuff out as part of populating your data warehouse, please, please, please reuse that stuff when you start moving into machine learning models as much as you can.
There, I'm trying to launch a few more questions here. This is not a question, but it's a statement. I'll read it. I don't know if you can see the Q&A panel. Uh, Dave, here's the question. Why are you so awesome?
um,
Thanks for all the buzz stripped best practice answers you always provide.
okay.
So why are you so awesome?
Well, first of all, I don't know if my dad would say that about me anyway, but or my brother anyway. Um, I if people think I'm awesome, that's great. It makes obviously I like to hear that. I mean, sure, I'm human after all. I am a little bit embarrassed and flustered if you can't tell. But um, here's the thing. I've just got burned a lot. That's all. Right? It's not like I came down from the mountaintop with truth and wisdom. I had to learn the hard way. Got burned a lot. That's all. So I just speak from my experience, and everyone's
Hmm?
mileage may vary a little bit.
Yeah, I maybe I'm a little too emphatic when I tell my boss I make mistakes. I make a lot of mistakes. I just try really hard not to repeat mistakes.
Yeah, me too. Unfortunately I'm not always successful, but that is my goal.
Yeah, I didn't say I don't repeat mistakes. I said I try not to repeat mistakes.
Right, exactly, right. Nice
Yeah.
weaselly kind of phraseology there.
And we got about I'd say about 8 minutes left. So again, if you have any questions, feel free to type those in the Q&A panel. Another anonymous attendee. We're getting good questions from anonymous. How does validation work with machine learning in general? Typical when we build DIMS facts for reports, there's already a data set out there that we use to tie out to ensure the data is good. How does this work for architecting fact dim tables for ingesting into a machine learning model? How do you
Okay.
know if you got good data? How do you know if you got good results?
Okay. So there's a couple things, right? So we have to forgive me, but as an enterprise architect, I used to be called Captain Pedantic. So validation in machine learning terminology means something different than like in an enterprise data quality kind of context, right? So
Mm-hmm.
validation is literally how do you validate the predictive performance of a model? So I'm going to put that on the side for a second and assume that we mean how do we know that the data that was coming into the machine learning data frame, the table that we feed into the algorithm to train the model, is good? And the answer is that typically most of the time there isn't any double check kind of validation, right? So in the old days, many, many years ago when I worked in BI and data warehousing, ideally what we would do is we would hand a specification for a dim or a fact, including like the mappings from the source systems and the transformations and all that. We would hand that specification to the engineering team and the testing team, and they would build two things separately, right? The engineering team would build the production pipeline, and then the testing team would build automation to test the pipeline. And that was basically a double check to validate that everything worked according to spec. Typically, you don't have that in most machine learning scenarios. Just like, for example, you don't have that when a user hooks Excel up to your data warehouse and performs some sort of analysis or pivot table on it. You have no double check. So is it a good idea to have those two in place? Absolutely. And if you make a production machine learning model, obviously that could be something you could add into the mix. Now, of course, that increases the expense of the initial development as well as the maintenance, but it's probably a good idea. However, I will say that that kind of double check thing isn't that common in practice. And I'm going to pause there to make sure I did not totally miss the nature of the question in my response.
No. There were two questions there, and we used validation for both. Validating the data in the star schema is one thing. Validating the results of machine learning is completely separate
Completely separate, yeah.
uh,
But
area.
something you have to do, by the way.
Yeah,
It's
yeah,
something you have to do.
yeah. I think the very first time I heard about machine learning was this is years and years ago. Someone was trying to train a machine to feed it pictures of people and to tell if they were happy or sad. And after feeding it hundreds of thousands of pictures and spending weeks doing that, they had trained it to tell when someone is indoors versus when someone is outdoors.
Right. And of course, there's also the unspoken thing of like what bias was there based on the distribution
Absolutely.
of the actual images as well. But we won't that's well beyond this particular talk today.
This is a good question. Again, from Mr. or Ms. Anonymous. Where do you recommend we get real world instruction and examples of utilizing data warehouse data in machine learning, besides Dave on data,
Uh,
or including Dave on data?
well, yeah, I'm not going to sing my own praises. Somebody else has done that for me. Thank you. That's a really good question because, quite frankly, and I'm going to be brutally honest, if you go out and you go into social media and you go out into the blogosphere or YouTube or something like that, what you're typically not seeing are tutorials or courses or videos or anything like that, blog posts that show you specifically, hey, I'm pulling all these features from dim date because date features are awesome. You don't actually really see that very often because there is an implicit assumption, and this was alluded to in an earlier question, that um, these quote unquote data scientist type people are just going against the raw transactional data. They're not actually using the enterprise assets, which I would argue is actually not necessarily true. And certainly that's something I wouldn't advocate. So unfortunately, I don't have any good examples of that. Maybe I should start doing that, quite frankly, based on the
Are there?
question.
We were at I'll just say a trade show, um, which was focused on training a couple of weeks ago.
Oh,
Uh,
yes.
I don't want to put you on the spot, but are there any particular certifications, any particular conferences, any particular classes, maybe remote classes at universities that you thought were helpful in getting a better handle on how to implement machine learning?
So there's lots of good resources for implementing machine learning in general. I teach courses at said conference that you mentioned multiple times a year. Uh, but I think the question was specifically around this idea of like showing using like, for example, a Kimball schema specifically as the data source and what you would do for that. And even my own classes actually don't do that because they tend to be more generalized, right? Because what you're trying to do usually when you're teaching people machine learning in general is you're trying to reach a broad audience. So you don't necessarily get too specific on particular technologies. But yeah, there's plenty of plenty of resources out there, right? You can go to YouTube and see tens of thousands of videos on machine learning, of course, right? I have a YouTube channel. You can check out some of my videos if you're interested in that, if you like me and my style. But I wouldn't necessarily that I say that I'm the be all end all in that regard.
Okay, well, we're coming up on the top of the hour. We just have about 2 minutes. you know, I always do these, and 15 minutes into it, I look at my watch and go, "We have to talk for another 45 minutes." And the next time I look at my watch, it's like, "What? We're done?"
Well, I
So,
take that as a
Dave,
compliment. Thank you.
yeah, I appreciate you joining us. I got a lot out of this, and I'm sure our other attendees did as well. We've got this recorded. If you want to watch it again, and you can reach out to you at daveondata.com.
Yep.
I didn't mention WhereScape too much, so I fell fell down on my duties as a WhereScape employee. But I will say that if you go to WhereScape.com, you can check us out. Again, the automation of building prototypes very quickly, building dimensional models or other architectures very quickly. It is a fantastic tool for accelerating the design, development, building of a data warehouse. Check us out at WhereScape.com. So, Dave, again, thank you very, very much. I appreciate it.
Thank you for the time. Hopefully, folks enjoyed it, and hopefully they find it useful.
Okay. And if you have any follow-up questions, feel free to reach out to us, either me, Patrick O'Halloran at WhereScape.com, more info at WhereScape.com, marketing at WhereScape.com. All those email addresses work just fine. And as I said before, you can go to WhereScape.com and check it out there as well. All right, Dave, again, thank you. Everybody, enjoy the rest of your day. Thank you for your time and attention.
Thanks, everyone.